and welcome back to AGT STEM. Today we're going to be watching a video about yttrium. So, without further ado, let's hop to it.
We're going to talk about yttrium, and we have some really nice demonstrations.
That looks pretty cool.
And a real first for periodic videos, we have a sample of a compound that has been given to us by the person who discovered it. So I'm really quite excited. Yttrium was one of the elements that was discovered in the Swedish mine in Yttrium.
So, we have reached our destination.
Pete and Brady have been there. I've never been there, but I have a rock from them. And with Pete and Brady's names
I like the signatures. It's amazing. Nice touch.
On it.
The Yttrium quarry, or Yttrium groover, which is actually the birthplace for 4 of the elements. And really, the one we're going to talk about now is this one here, yttrium.
Part of the reason for talking about yttrium again is that we've been given a really nice sample of yttrium metal by our fan Anthony Lippmann, who gave us this really nice lump. And so we could do all sorts of experiments that we couldn't do before. Yttrium itself was discovered as an oxide, or isolated as an oxide, in the end of the 18th century, but it wasn't isolated as a metal until the 1840s. It was isolated by German chemist Friedrich Wöhler, who managed to publish a paper in which he described discovering metallic beryllium and metallic yttrium in the same paper.
So he discovered both metallic beryllium and yttrium. And it'd probably be super cool, and also like an honor to be able to be the first person to figure out something like that, and for them to have a sample from someone who discovered yttrium, it's probably super cool for them.
Nowadays, people would write many papers about such a discovery, but he put both of them into one paper. Yttrium itself forms a whole series of salts, the sort of things you would expect. We were given a nice sample of yttrium chloride, but most of their salts are colourless. So it was quite a challenge to try and make a coloured salt of yttrium. So we filled a series of test tubes with a solution of yttrium chloride, and then Neil dropped different chemicals into each test tube. The first one was sodium sulfide, which was a bit disappointing, but eventually produced...
Didn't really do much, or at least it doesn't look like it's doing much right now.
Just a whitish, cloudy precipitate. Then potassium carbonate produced really quite a nice precipitate. The one I liked best was adding chromate solution, and something really strange happened. As the drops went in, chromate is a yellowy orange colour, a precipitate formed, which then seemed to redissolve. But as we put in more and more chromate, we got more precipitate, and eventually a yttrium chromate precipitate formed. So we had made a nice...
So at first it was just making the precipitate and then dissolving again. But with enough of the chemical that they added in, it made it all together.
Yellow salt of yttrium, though the colour itself comes from the chromate part rather than the yttrium. Then Neil decided he would file a bit away from the side of the block of yttrium and he took those filings and sprinkled them into a Bunsen burner flame.
Wow. That's very pretty. It's like little tiny stars. Kind of like a sparkler.
And he got some really bright flashes of light as these particles of yttrium burnt in the flame. He thought it would make a wonderful firework, and you know Neil loves fireworks.
It probably would
But
make a wonderful
it was almost
firework.
magical, these sparks. Yttrium has the symbol Y for Yankee, if you like, but I read that originally the symbol was YT, and I didn't really believe that. But then I looked in this book here, which was my father's chemistry book from 1927, and there on the periodic table in the book there is the element YT. Why the
So it is, or at least it used to be. I wonder why they switched it. Maybe they'll talk about it. Who knows?
the symbol changed, I really don't know. It is one of only a few elements that has a single letter as its symbol, things like nitrogen, oxygen, and so on. So there are two applications we want to show you. The first one is in so-called high-temperature superconductors. This is a compound of yttrium, barium, and copper with oxygen. And this material has a strange property that it loses all its electrical resistance at a temperature above the temperature of liquid nitrogen, 77 Kelvin. So if you pour liquid nitrogen over it, it becomes superconducting. And superconductors can act like a mirror for a magnet. So if you put a magnet just above it, the magnet, as it were, sees its reflection and is repelled. So Neil managed to float a magnet above a small sample of this high temperature super.
That's pretty cool. If it's cold enough, magnet will float. If it gets warm, magnet will drop.
Conductor. People say high temperature. It's still pretty cold, but it's a much higher temperature than most superconductors, which are only superconducting at 20 Kelvin or even lower temperatures.
Yeah. It warmed up and then fell.
Then our colleagues in physics lent us a demonstration of high temperature superconductivity where they had made a circular track out of magnets, a really large number of magnets, I didn't count them, and a little wagon, like a train, with two pieces of superconductor in the bottom, and as it was cooled, the wagon levitated and you could push it round and round. And Brady,
It's pretty cool. And it's also pretty cool. Like, it's really cold. Don't touch it.
and Neil got really excited. I could hardly stop them playing trains. And they decided to torture me by putting a Model Martin into the wagon. And the wig came off. Fortunately, my hair is real. It's a really nice demonstration of the Meissner effect.
But it's not just yttrium in the superconductor,
No,
is it?
it's yttrium, barium, and copper, a mixed oxide. And this mixed oxide has a structure which allows the electrons to flow freely at low temperature. The other application, which was discovered, I think, by chance, is also an oxide, and it's an oxide of yttrium, indium, and manganese. Yttrium and indium form a mixed oxide, which is white, and yttrium and manganese form a mixed oxide that is black. But if you make a mixture of yttrium, indium, and manganese in an oxide, it forms a wonderful intense blue colour.
That makes no sense. With the two, it's black, but then with the other two, it's white. But how did we get blue?
The first time I've seen Neil get really excited about the colour of anything. This compound, which is called colloquially yin-min blue, was discovered by a chemist at Oregon State University called Mas Subramaniam, and he sent me a sample of yin-min blue. I heard about it on the radio, I emailed him, and he sent us a sample. The reason that people have got so excited about this compound is that it is the first blue pigment that has been discovered for 200 years. A pigment is a highly intensely coloured material which you can use in paints. Until the 19th century, people used the mineral lapis lazuli, which is found very rarely in Afghanistan.
It's very pretty, and I'm sure it's probably easier for them to use yttrium or yin-min blue, whatever else is in it. I'm sure it's easier and probably cheaper than using lapis lazuli. I don't know how to say it.
Which is why in medieval times blue paintings were so valuable. And then an iron cyanide compound, Prussian blue, was discovered in the 19th century. Then, about 9 years ago, Mas and his colleagues found this compound, which is pretty indestructible. Neil and I tried to dissolve it in nitric acid. It wouldn't dissolve. We tried to destroy it with aluminium powder in a sort of thermit reaction. But finally, we managed to show if you take the damp powder and put it in a flame, you can see the really nice violet colour of indium. You remember that indium is called indium because it gives an indigo flame test, a sort of purpley violet flame test. I found yttrium far more interesting than I expected. I hope you will too.
If you want to help out Periodic Videos, you can support us on PayPal.
Thank you so much for watching. We'll see you next time. Stay smart. Bye.